So a couple of years ago we built a Venturi aerator and we never put to test. We never checked if it was working. So it's finally time to put it to test, see if it's working actually. So we submerged like a 10-meter pipe into the creek. We got around 30 centimeters of head height maximum, something like that. Pipe is over there, and we installed the Venturi aerator right at the end of this pipe. So let's see what's going on. So as you can see over here, there are already bubbles forming on the outlet, so all we get is bubbled water at the end. This is where the air is being sucked from, so most of the system is submerged. Only this part is out of the water, so it can suck air. And you can see the bubbles forming over here. It doesn't come with much pressure because the head height that we got was only like 30 centimeters maximum. So this is all we got. You can see that if I just put my hand over here and block the entrance of the air, the bubbles stop forming. Right? Let me zoom a bit. There are no bubbles. If I remove my hand, you see directly the bubbles start forming. Right? Can do it again. Block the entrance. Slowly the bubbles stop forming until they completely stop. Right? One bubble now, zero bubbles. Remove my hand. Directly bubbles begin to form. So bear in mind that when I was gluing this whole thing, I accidentally glued and blocked half the holes of this system. So the bubbles that you see right now, imagine them double or maybe triple. So I will do it again. Well, that's why I probably never tested it, because I overglued it. But this is it. Now, one thing that we will do, we're asked to, so this might not be a high pressure aerator, but it is a constant aeration of water. That means that all the water that's coming in is coming oxygenated. So if you have like an integrated aquaponics system where every day you renew your water in the tank, all the new water that is coming in is coming oxygenated. So it sucks air out of the atmosphere. So this works well in a full pipe. Now what we're asked to do, and we will do it, to check how it would work in a pipe that it's not so full, right? Half full or a quarter full pipe, to see what it is. You can see it's a constant aeration of the water, non-stop. As long as water is coming in, it's being oxygenated, right? So let's see how this actually works. You have water coming from this end, right? Over here the pipe narrows and then widens again, so this creates a difference in pressure, which actually is the physical function that creates suction and sucks air out of these holes. So all you need to do is have a narrowing and widening pipe, and then install inside another pipe that will be sealed from the outside over here but open to the air. This is how it looks inside. I have installed some kind of plastic things which I drilled a hole in them and cut diagonally towards where the water is going to create the suction. But you can just drill some tiny holes over there and not overglue everything and block it so it functions at 30% capacity like I did. So that's it. So we're gonna test it in a different system where we have a pipe that is not completely full. So we're gonna test it at this pipe. This pipe is not full, it's like 1/4 or something like that, coming and going. And we're gonna install our Venturi aerator here, submerge it into the creek and see if it actually works with a pipe that is not completely full. Right, so I guess that you can do that if you play with the diameter, if you try and make it narrower so it gets full where it gets narrow, then it should work. Right. Or if you have multiple pipes in an aquaponics system, you can connect all the pipes to one and have a full pipe. But let's test it over here to see if it works with a less full pipe. Alright, so we tested our Venturi aerator in the pipe that was not full. It was about 1/3, 1/4 of its total capacity. And we got some interesting results. I actually didn't expect that. Not only it doesn't work at all, you can see there are no bubbles forming at the outlet. There is also the fact that this part that was supposed to suck air, actually water is coming from the hole upwards and going up to the level of the water. So it doesn't work at all. I guess that's because there is a lot of air in the pipe, although this pipe runs up to 15 meters high, so we would supposedly get a lot of bubble pressure over there. With the other pipe that was just 30 centimeters, not 15 meters, we got a lot of bubbling action. So we're gonna test something else. There is a solution to that. We're gonna test something else and come back to this. So we got rid of all the air in the system, and now it stopped. What the fuck? Right, and now it spits out correctly. Right, the Venturi is working and it spits out air as it should do. Right, so apparently, if you add a Venturi aerator just at the end of your pipe, and you don't even have to have it submerged, the water that comes in oxygenated by principle, right? Because it always sucks air from here. So all the water is coming in, it's already coming oxygenated, even if the pipe is not full, right? Although the fuller it is and the bigger the pressure, look, you see that? So all you need is just a Venturi aerator just right before your pipe, right? And all the water comes in oxygenated by principle, because it sucks air out of here. course it depends also on the velocity. So what you can do, if you have little flow from different pipes, you can connect all the pipes into one, or you can restrict the flow of the water by making like a Venturi aerator very small, very narrow, right? So it restricts the flow of water, so it's always full, so it always creates this suction feature, like over here. You see that this is not a constant flow, that the water comes oxygenated. See, right? Even if I have it outside, if I manage to restrict the flow over here, now that it's not coming, it doesn't get oxygenated. But if you restrict the flow on the bottleneck over here, you're gonna have oxygenation of water right now.